Chapter 64, solving radical equations. Solve square root of x, which is 5. The answer is x is 25. This quick guess was quite simple, but we need to develop a technique to solve more challenging situations. Given square root of x, which is 25, multiply both sides by 25. Replace the 25 by square root of x. You get square root of x squared, which is x. And x is 625. Okay. So we are not finished yet. Whenever we go through the process of squaring both sides, after we isolate the square root, we must check our answer, because some of the answers that we get may not be valid in the original equation. We're going to call that an extraneous solution. Note that we went from square root of x, which is 5, to square root of x quantity squared, which is 25 squared, which means we squared both sides. It is imperative that we check the answer. The process of squaring both sides may have introduced extraneous solutions. Suppose we had been given square root of x is negative 1. Then squaring both sides leads to x, which is 1. But square root of 1 is not equal to negative 1, which is false. Thus, x, which is negative 1, there's a misprint here, it should be negative 1, is extraneous. And by the way, didn't we say once that the square root of a number could not be a negative number in the real number system? So we could have stopped right there. We didn't have to bother to square both sides and check. Examples. Solve the equation square root of x plus 5 minus 8, which is 0. A comment, make sure that the sign, that the length of the bar of the square root extends as far as it needs to. Not further, and make sure it's long enough. Add 8 to both sides. You have isolated the square root. It's no longer square root plus or minus something. You square both sides. The square root drops out. It becomes x plus 5, 64. Divide by 9, subtract 5. You get x, which is 19 over 9. We must check this answer. So 3 times square root of 16 over 9 plus 5 gives you the square root of 68 over 3. The 3 drops out. 8 minus 8 is 0. This works, yes? So x, which is 8, is a solution. It is the solution. Solution is unique. If the original problem had been given as square root of x plus 5 plus 8, you subtract 8 from both sides, you're done. The square root cannot be a negative number. Okay, we are going to solve this anyway. Oh, this is a different problem. Square root of 5x plus 8 is 13. Isolate the square root by subtracting 8 from both sides. Square both sides. X is 5. Check your solution. Square root of 5 times 5 is just 5 plus 8, which is 13. So x, which is 5, is the solution for example 2.